So, my friends, this day is very special for us, students from Consciência. We have here the great participation of Dr. John Hunt, right from Mississippi College, to, to teach you, to make inspiring you how to create some scientific experience with STEM for the kids in the public schools. So, John, it's an honor to have you here. I'll tell this, the class is gonna be recorded, so everybody will have the access after if you want to watch many times to learn everything. Okay, we have Iris family with us. So nice to see you here. Thank you so much for coming. So, John, the class is yours.
Professor Antonio, thank you so much for inviting me into your class. I'm looking forward to this. And Dr. Malady and Dr. Rosano and Iris, nice to see you all too. Our pleasure. Okay, let's start.
My pleasure to see you again.
Well, it's nice to see you, sir. It really is. Nice to see you all. And you all look so healthy. No problem with COVID, huh?
Yes.
Yes.
Yeah,
Thank
we've
you,
all
John.
been,
Survived.
we've been vaccinated here.
We are surviving.
Where's my what? Where's my wife? Where's I've lost the video. Lost the video.
Oh, sorry. They were saying that
Okay.
they are thankful that they're
Oh, I've lost it.
survived it. You lost your wife?
I've lost you. Okay, I see you now.
Yeah.
And what did you ask, Dr. Malady?
I wanted to ask. O que você queria perguntar?
I don't know. Where is Katy? Where is Catherine?
She's coming right now.
Ah, okay.
Go on, sit down so I can see you.
Katy, nice to meet you. Nice to see you.
Okay, Catherine. All right, let's start. Let's start the things that I've got for you today. Okay, here we go. Maybe some of you have seen this. Have you seen my flying tea bag? Have you seen my flying tea bag? All right, here you go. All right, dear. One of the things I noticed when I taught young children, especially my triplets in Texas, they invited me to come over and teach some science kinds of experiences to them. They were in the second grade, so they're what, 7 years old, 7-year-old students. And they were all on piers in the music room. They were up on different levels. And I pulled out my match, like you see here. I don't know whether you can see it. There you are, you see it there. You see the match? It's a long match. Really a long match. I pulled this match out and all the kids stood up and they gave me a standing ovation. They started clapping. They thought that this was the science activity, just the match. It's because it was so big, they thought it was something, they had never seen it before. So I'm going to use that match. And in my pocket, can you hear me?
Yes.
Can you hear me? Okay. In my pocket, I have a tea bag. Can you see this? Let me get this so you can see it. Well, where is the camera? Here's the camera. Let's see. Can you see the tea bag? I got a tea bag. Okay. I'm going to cut that tea bag. I'm going to cut it at the top. And I'm going to take out the tea. What shape do I have here? What is this shape? Let's see if you can see it. There it is. What's the shape? What is it?
Rectangle?
the shape of the thing I've just cut.
Is it a rectangle?
It's not a rectangle, no, because it has a hole in the middle. There's a hole down there.
A cube?
Okay, sort of, you just stretch it a little bit. It's a cylinder,
Oh.
okay?
Yeah.
Now I'm gonna move my tea leaves over here. And I'm gonna light this match. Can you see the flames?
No.
Okay, now I'm gonna light it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, lift off. It went up all the way to my ceiling. And now the question is, why? Why did it go to my ceiling?
Who's gonna try to answer? No problem, can answer. Anyone to try to answer? Why?
The air inside was warming. The air inside the bag is heated.
Dr. Rosano,
Yes.
correct. There was a column of hot air that went up all the way to my ceiling inside that cylinder. Okay.
Okay.
And the tea bag was made up of very crude ash content, very low ash content.
Yes.
The very low ash. And so when I lit that, it caused the column of hot air pull that tea bag up. So it made it fly up. And when the tea bag flew up, it flew up in the current, and that created a convection current. Now the tea bag came down, the ash from the tea bag came down and landed on this table here. Okay?
Okay.
And this is very important concept to teach because weather, our weather is based upon that. Hot air rising, cool air falling, and you get this cyclic thing. My students always loved this tea bag thing. And it was a 12-year-old student in one of my classes that showed me how to do that many, many years ago. I don't know what that student is doing now, but that was nice of them to show me that. All right, the next one. Any other questions? All right, the next one. I've got a piece of paper. Can you see it? I don't know what my camera is doing. Where is my camera? Oh, it's over here. Ah,
I think it's better if you turn off the virtual background, because when it doesn't censor your face, it just doesn't show all the other things.
okay, how do I turn the background off?
There is a button above the stop video.
Is
You
that
just
off?
click-
You go in
No,
the video,
it's-
you
it's
go
still-
where it stop the video, and then you choose a camera. Then you said choose a filter of video. Then you go there and say no filter.
Okay, wait a minute. Choose a filter, switch camera, switch to gallery view. Huh. I don't know where the filter is.
When you
Choosing a filter is written choose virtual background.
Yeah, shit. One moment. Okay. Shall I turn the camera off?
no, your camera is on.
Okay. Virtual background.
Mm-hmm.
That's off now.
No.
Is it off?
No.
No. Shit. Come on. I don't know how to turn it off.
You're on iPad.
I'm on an iPad. Yes.
Okay, in iPad is a little different. You're gonna go in the three dots.
Yes, I've got the 3 dots. Oh, it says,
And
Marion, pick the
then-
background color.
And you have three dots, and then you click it, and then it's gonna be something camera or background in settings.
Green screen. No, I didn't do it.
Put your finger up in the top left-hand corner. on
No,
the
that's
black.
okay. Perfect. Now that's it. Now you're normal.
Are you normal now?
Yeah.
Yes, we are. You see my wife at the back.
Yeah, I can see her.
Okay, let's go to the next one. Do you see that? A sheet of paper. A
Yes,
sheet
you
of paper.
can see.
All right, now. I want to change this sheet of paper physically. How am I going to change this physically?
Folding it,
Do what?
fold it.
Fold it? Okay, let's fold it. I'm going to make it easier. I'm going to do it this way. We call this hamburger or hot dog, and this one is hamburger. All right. All right, I folded the paper. See it? Okay. And take a pair of scissors, and I'm going to cut this. And a physical change is one where you change the thing physically, but you don't change it chemically. Now, the smaller I make these cuts, the bigger the thing is that I'm going to make at the end. And I can walk through this paper at the end. All right, I've cut it. You see the cuts? And I cut it on the folded end, folded side. I turn this over, take the two ends and fold it down. Fold this end down. All right, I folded the two ends down. Here's an end. And here's an end. Now, I'll take my scissors. And I'm going to cut along the edge, the crease.
I don't think they can see you doing that.
They will, they'll see me in a minute. All right, I've cut it all. It's all cut. Oh. Guess what? Guess what? I did it wrong. Even I can do it wrong. Let me start all over again. All right, crease it. Cut this. Cut it. That's the reason why I got two sheets of paper, in case I made a mistake. I'm going to change the physical proper. I'm going to just change the physical shape of this thing. All right, I cut it. Now I turn it over and I cut it this way. Not all the way to the top. I'm going to show you to this. Not all the way to the top. I'll do one of these for you. I cut it close to the top. Next one. Cut it close to the top. Next one. Close to the top. Next one. Close to the top. All right, I take my two ends and fold it over. I folded that end over. Take this end, fold it over. I folded it over. I don't touch that. I just touch this. I'm just cutting the crease. Remember, we started off with a crease, a folded edge. Now I've done it. Now I'll take it. And there's a physical change. And I'm going to take this and I'm going to walk all the way through it. I walked all the way through the paper. I'm going to stand up. Now I get the students, when they've done this, I get the students now to put it all back and make the sheet of paper. Some can do it. Usually the girls can do it. I hate to say this, boys can't do it as quickly as the girls can. And that is a physical change. How do I make this into a chemical change?
You can burn it.
Burn it. That's correct. I'm through with that one. All right, the next one. All right, on this one, I have some toothpicks. Flat toothpicks. Oh, where's the camera? Here we are. Flat toothpicks. They're flat. And I've got a plastic sheet of paper. Okay. I'm going to take 5 of these toothpicks and I'm going to split them in half and make a greater than or less than sign. And I'm going to put it down on my plastic. I'm going to get 5 of these. This does not work with a square toothpick or with a round toothpick. It has to be a flat toothpick. Now what I'm going to do is there's a wide end and a narrow end. I'm going to put the wide end to the narrow end. What I'm doing is I'm joining these two together like this, and I'm going to put 5 on this sheet of paper. 5 toothpicks, splitting them in the middle. That's 3, 4, 4, and I've got 1 more to go. And I'll move my camera so you can see this. 4, and this is 5. I'll put it this way like this. Okay. There we are. Now take the camera. Come on now. Can you see it? Can you see it?
Yeah.
Yeah, we can see it.
There's 5 toothpicks there and they're all in the center. And now this is what I'm going to do. They're in the center, and I'm going to take a drop of water and put it in the middle. Watch what happens. I'm just going to take one drop. There we are. Ah, oh, no. Oh, no, no, no.
You return to the background.
Yeah, I got to get that out of there. 3 dots.
Yes.
There we go. Now, can you see what I created? Or you can't?
Not yet.
Well, let's do it this way. Let's go around here like this. Oh, darn background. And if you can't see it, can you? You see my cat food there. Can you see it? No?
Because the background is back again.
I know, I gotta get it out of there.
No, it went off.
Well, I know one thing.
Wow.
You see anything?
Yeah, you can see it.
Do you see it?
Yeah.
What did I form?
A star.
A star, a 5-point star from 5 toothpicks. How did I do that?
Anyone is gonna try to explain?
The water that you put in the middle of the toothpicks spread them apart, and the point of each one formed a point of the star.
Correct. The water went into, you remember I broke the toothpick in the middle. When I broke the toothpick in the middle, I allowed the wood to show the xylem and the phloem tissue. The xylem is a vessel that carries water from the roots to the leaves. And so the water through capillary action went up the xylem tissue. And as it traveled up the xylem tissue in the wood toothpick, it caused the toothpick to spread out. And it spread out, forming a perfect 5-point star. That's how water goes up in a tree. It's through osmotic pressure from the roots all the way up to the leaves. In the leaves, there's transpiration. And as the water is transpired, the water from the roots is pulled up through the xylem tissue, the xylem vessels. Any question?
Anyone has a question? Not yet? Okay. Don't worry, because we are recording, so you can watch anytime, can review and see, for you to repeat with your kids and create the activity for your kids, okay? Good.
Now, do not do that with the same toothpicks over and over. It does not work. And it has to be done on a very slick, a very smooth surface. And you need to use dry toothpicks. So if you do this repeatedly for your students, just dry off the plastic sheet, get rid of the broken toothpicks and put new ones down. And these are the toothpicks that I got. Diamond toothpicks, flat. I had to order them from Louisiana because I can't get them in the store. We don't have flat toothpicks in our stores up here. They're used for making cake. You know, they use the flat toothpick to test to see if the cake has been cooked enough. Okay? All right, the next one. Now we go into a STEM one. And I'm glad my chemistry professor is here because he'll see something. Maybe he has seen this before. And we're going to do this now. Let's see if this is the one I want to do. Let's see, I've done that, done that, done that. Oh, I'll do this one first. Okay. I've got a jar. And I'm taking a piece of 100% cotton. 100% cotton. I'm going to put this over the jar. By the way, here's my jar. And I gave you, Professor Antonio, the dimensions, the diameter of the jar.
Okay.
Okay, and I've got a rubber band on here. Here's a rubber band. And I'm going to take this and put this on top. And I'm going to put this around the cloth. I'm going to make sure the cloth is tight, very tight. And this is what I have. It's on here tight. Okay. How are we doing time-wise? Okay.
Okay, perfect.
All right. Okay, there we are. Now, I've got some permanent ink here. This is a Sharpie 5-point permanent marker. And this color is green. I got a green, a blue, upside down, but there's the blue. I got the black, red, orange, going a little faster here, purple, and brown. You don't have to have all these colors. I just brought them all out. You can use whatever you want to. Okay, that's what I'm going to do now. I'm going to take the red and I'm going to put red dots in the middle. I'll show it to you in just a minute. There's my red dots. You see it? Do you see them?
Yeah.
Okay. Red dots there. And then I'm going to put blue ones on the outside. I'll put one in the middle, a couple in the middle. I put some green ones here. Okay. You see my array of dots there. What I'm going to do here is radiochromatography. I'm going to make a radiochromatogram. This can be done on a 100% cotton t-shirt. Just make sure that you put the top of the t-shirt over a glass. Don't put all the t-shirt over the glass, just one part of it. You slide this underneath the t-shirt. Okay, now I've got some alcohol. 91% alcohol. And alcohol is a solvent, It's just going to separate something for me. I'll pour a little bit into this cup. Put the top back on. You could use, if you wanted to, you could use one of these squirt bottles with the isopropyl in it or rubbing alcohol in it. You could use that. But I've decided to use this. And I've got a little pipette here. Pipette. I'm going to take this and I'm going to separate the colors here. I just dropped this. I just dropped this on top. And let it work. Let me just have a few seconds and let it work. It's spreading all over the thing. And there's a radiochromatograph. And all I used was permanent ink. You can't use water-soluble ink because if you do that, it'd just go all over the place. This one is retarded. The colors are slowed down when they go into the cotton fiber, which again, the cotton is a plant, so it has xylem tissue and phloem, has xylem that carries the water. You notice that the red color does not move very far. The red pigment doesn't move very far. It doesn't move very fast. But you notice that the blue pigment moves very, very quickly. The blue was all the way around the red. You notice how far it went and how quickly it went. You can come up with all sorts of designs when you use these radiochromatograms, and the kids can create all sorts of creative stuff with this. You take this off, and I'm going to show you a different technique in a minute. You take this off, and there's my radiochromatograph. And let it dry. I'm going to do another one with 100% cotton. Here's another piece of 100% cotton. And I'm going to do this a little differently. Watch this one. Let's get my rubber band on here. I believe that when you teach children science, well, any kind of science, whether it's STEM, whether it's chemistry, whether it's earth science, whether it's physics, that you should do a lot of hands-on kinds of things for them to understand the concepts. All right, this is like we had set up before. And for the students that are listening to me, this is my 60th year of teaching. I've been doing this for 60 years. And I love it. Let's do the red again. All right, there we are, red. And let's put some orange in this. All right. And let's put the blue in there because we know what the blue does. And I'll put some green in the middle. All right. This is my setup this time. See the dots? The blues, the greens, the reds, so forth. This time, I'm going to drop the alcohol in the middle, and I'm also going to drop it on the side. So I'm going to drop the alcohol on the side as well as in the middle. Watch now what happens. And this is what I got this time. Okay? Just a little different. And you can get them to be scalloped. You can get the outside to be scalloped. What I've seen students do with this is they put this on t-shirts. I just don't have a t-shirt to show you, and they make different design. In fact, I had one teacher that used this technique to make a bear. She finished wearing a t-shirt with a bear and using chromatograms or using this radiochromatography. Remember, the red travels at a slower speed. The blue travels at a faster speed. Any questions? So there's one, and there's the other. There's the other, and this one here. Okay, any questions?
My mom said that she teach it in the 4th grade when we were in 19, a way to do this with chlorophyll.
I didn't hear that very clearly. What did you say now?
My mom said that she made the experiment showing the event with plants with chlorophyll.
With chlorophyll, yeah, with the pigments in chlorophyll.
Yeah.
That's great. That's a great idea. Great idea. There's different ways to do it. In fact, a fellow received his doctor's degree. I don't remember the university. I think it's up there in New York, where he was doing using these Sharpies. He was determining what the refraction rate was for all the pigments. And he did an extensive study that showed that red moved very, very slowly and that blue moved very quickly. And he did all colors. He did blue, red, and then you could take the black afterwards and outline it if you wish. You could do all sorts of things. When they did the bear, for example, the teacher took a black mark and outlined it. Okay, thank you. Any other questions? All right, that took care of that one. Oh, by the way, there's a limit on the size of that. They cannot grow any bigger than 10 centimeters. If you do, they become very disfigured. You don't want the diameter to be greater than 10 centimeters. Okay, next one. This is another one that's got a little chemistry twist to it. I've got a styrofoam plate. All right, and I have a paint spreader or a mud spreader you use for spreading mud on the wall. And I have pieces of paper. My wife did this. I cut up pieces of paper. Just little pieces of paper. White pieces of paper, I'll be using that. And for this one, I'm going to put a piece of newspaper down on the bottom. That away. All right. And I've got my scraper. I've got this. What happened to my... Oh, interesting. Well, that's all right. I've got another one. This one, I'm going to use round toothpicks. Last one, I use square ones, flat ones. This one, I'm using round. I've got the round toothpick. All right, now I've got my foam. You can only use shaving foam. Don't use shaving cream. Don't use shave cream. Use shave foam. Okay. Shake this up. Take a little bit, squirt it on the bottom. There we are. Wipe that on my coat. All right. I've got a big blob on here. I'm going to cover the bottom of this. I'm going to spread it out. I'm gonna take this and wipe it off. Don't want that. All right, this is what I have. I just covered the bottom of this styrofoam. Don't put it on this side. Put it on the bottom side. All right, now I'm going to use this one. I'm going to use food coloring. And the shaving foam is a colloid. It's neither a solid nor a liquid, but it's a solid, liquid, and gas. That's what the shaving foam is made up of. All right, I'm now going to take food coloring. Food coloring. They use this for cakes in the United States. I think you have it in Brazil. Because you have great food in Brazil. I especially like the steak food that you have, the steaks. Now, I've dropped some red on here, and you notice the red hasn't gone anywhere. It's stayed there. That's red food coloring. Now I'm going to put a little bit of green in here. Don't worry if you get this on your hands because you can wash it off. Put a little bit of green on here. Green. Got the red, green, blue. You can put as many drops as you want on here, different colors. I put a little bit of yellow in here. I have yellow, so I put a little yellow. There we go. That's enough. All right, so I just put drops of food coloring on here, okay? Now I take my toothpick. Now you don't want the children just to take a toothpick and take it and go like this. Go like this. You don't want them to do that. Do some little squirrely tails to the thing like this. All right, this is what I've come up with. See that? Now I take my piece of paper. I'm going to put this right on top. I'm going to put this right on top and smash it down just a little bit, push it down on it just a little bit. Now I'm going to take the top off. Take the top off. Put it on my paper towel. Take my scraper and scrape it. And this is what I got. You like that? Pretty, isn't it? All right, now, let me tell you the science behind it. That came off, and you can take another piece and do the same thing. When I did this with children, I get them to write their names on the piece of paper at the bottom and then let them dry. And then I gave them to them at the end of class. I can take another one. Take as many as you want. Take it off carefully. Take my scraper and scrape my thing. And there it is. There's two of them. One there and one there. The science behind this is this. A colloid. It's got soap. It's got a liquid. You got a liquid, a solid, and a gas. The shaving foam has gas in it. You've got the soap particles in there, soap solid, and you got a soap liquid. So it's a colloid. Now, What I'm showing you here on this is this, that the actual food coloring, the head of the food coloring molecule is hydrophobic. It will take the color in. The tail of the molecule is hydrophilic. It takes it away. And so you've got it moving just because I got it to move. Otherwise it wouldn't move in there. Water won't do it. You have to just use the colloid and use the food coloring to create that. You can make, what I've had students do with this is they've taken little pieces of cloth. You can do this on a t-shirt or on pieces of cloth and then sew them together and make a blanket, make a covering for a bed. So you sew it together and make a covering, bed covering using these. And this is permanent, by the way. It won't come off. Of course, unless you wash it in a machine, but otherwise it's on there. The paper has absorbed the actual color. All right, that's done. Okay. Now, my last one that I've got for today, and the time-wise are going pretty good, is this. I'm going to make a rocket.
Wow, rocket, great.
A rocket. Wow, a rocket. All right. You need a plastic bottle with a narrow mouth. Don't get the drinking water glass jar. The plastic on the drinking water bottles is too thin. You want a thicker one, a thicker one. Now, here are 2 straws. Let me move that away. This straw barely fits into this straw. I'll tell you a funny story. I wanted these straws and I couldn't get them at Walmart. So I had to go to a place called McAllister. It's a hamburger place. And I told my wife, who has a nice big purse, to take the straw. They use this for iced tea, for drinking iced tea. I said, go up to the counter and put a lot of these things in your plastic, into your bag. And I'll have some for my students. So we did that. And then the manager asked, or somebody behind the counter asked, what are you taking all my straws for? I said, I'm doing something in science with my students at the university. And they said, look, I'll give you a big box of this stuff. So he gave me a big box of these big straws. But this fits very nicely over the small one. Okay, here's my bottle. And the other thing that you need, is modeling clay. I know you have this in Brazil. You may have to look for it. It's called modeling. Let's get this right. Modeling clay. Okay. I'll take this off. Plastic off. And just as the name implies, modeling, you can take it and you can move it around in your hands and it's modeling clay, okay? Now what I'm going to do with this is I'm going to make a snake out of it. I'm going to take the straw. Here's the straw that I'm going to take. And I'm going to put this in the center of this bottle. Maybe I should use a different color straw. Here, let's use this one. Okay, I'm using a yellow straw in the center of this thing. Take my clay. Notice I'm putting it around. I had some students that try to stick the straw through the clay, and of course that doesn't work. Put it all the way around. I've got too much clay on this. You can do it with a lot less. I've got way too much clay. Okay. And I'm squeezing this. Okay. Now, I take my straw, and this is where the stem part comes in really nicely here. You're asking the students to make a rocket that when you use Newton's third law, which states that for every action force is an equal and opposite reaction force, Newton's third law of motion, that the different length of straw, will that make the rocket, help the rocket to go farther? The different mass. All right, I take my straw. Here's my straw that I've got. Let me move that away. Here's the straw I've got. And I'm going to cover the top of this with a little amount of modeling clay. And there it is. There's my rocket with a little clay on the top. I'll take the rocket, put it on here, barely put it on there. There, it's on there. There's my rocket. Now you don't have to use all this clay here, a lot less than this. All you got to do is seal this, make sure it's sealed. Now I'm going to take this and I'm going to push it. I'm going to take my hand and push this thing. Watch what happens. The rocket fired. Where is it? It's somewhere in this house. Oh, there it is. I got it. Now my question is, how did this work?
Anyone would like to answer the Newton laws, third law of Newton? People there in the second high, you can have the chance to explain.
How did this work? You know, you can build these things and make these things, but you've got to teach something with them. Otherwise, I don't think they're useful.
Can I try to explain
Sure, Luisa, try it.
Try to-
I'm not sure, but I think that how this works is that the air that is in the bottle, it goes into the bigger straw, and the straw fill up with air, so it push the straw away.
Very good. You must have seen this somewhere else, Iris. That's very good. Very good explanation. Okay, what happens is this. When I put my hands here and push this in, there's a lot of air in here. The air goes inside this yellow straw, goes inside, and when it gets to the top here, it can't go anywhere because this top now has this rocket with some clay. And so where does the air go? It goes back through the red straw. It comes back down, comes out, and as it comes out, that's enough energy for this to be released. Newton's third law of motion using a plastic straw rocket. Now, with the children, you could have a dartboard thing with 50 points on it, 30 points, and get the children to stand back and you line them up, and then they get their rockets and they shoot towards that target. My question is, what's the angle that this should be at? Should this be at 60 degrees to get a greater distance? Should it be at 45 degrees, 60 degrees here, 45 degrees here? Should it be 80 degrees? What's the best angle for the greatest distance?
Well,
45 degrees.
What kind of degrees? Yes.
45.
What was that?
45 degrees.
You think 45. Well, you would test it and test it and test it, and you use the same rocket size. What would happen if I put on here a bigger rocket? A much bigger rocket. Would it go farther? At the same angle, 45 degrees. What would happen if I cut this up into a very small rocket? Like this. Will this go farther now? What do you think?
I think that is gonna go farther because there's much more air into the bottle, and you don't have to fill all of the air. So you have more how can I say, like, you have more air to push the straw away.
Your English is very good, Iris. Very good. Excellent explanation.
Luisa is talking.
Oh, Louisa, go ahead. Sorry.
It was Luisa, not Iris. No, John. Who was talking to you was Luisa.
Oh, Louisa, very, very good, Louisa. Very good. You sound like Iris, and your English is excellent. Well done. So, well, there's another variable here. And the other variable is that this is less mass. If this is less mass than this one, which one will go farther? With the same amount of energy applied here in the bottle, on the bottle. Will this go farther or will this go farther?
The air creates a bigger resistance with the smaller mass.
So you think with the less mass that it'll go farther?
Yeah, because the air creates a smaller resistance. So the pressure goes really goes in the straw really well because it doesn't have that much of the air resistance.
Very good explanation. Very good. Well, to get the answers to all of this, you need to do it. You need to work on it and see what you come up with. Okay. But those are the 5 things I was going to show you today. And maybe down the road, I can show you some more. It all depends upon Professor Antonio, whether he wants anything more. But you notice that the things that I used today was very simple materials, not complicated. I found out though in schools, the children can't do this without simple materials. And these materials that you've seen today are materials that we can find very easily here, even during a pandemic, they can find this stuff. The large matches, for example, are used for lighting barbecue. These are barbecue matches. They're not house matches, they're barbecue for grills that you have to stretch your hand out to light the fire. Okay, well, that's my lesson today, and I hope that you've enjoyed it.
Anyone would like to ask a question to John? Any question? Any
Feel
comment?
free to ask me anything. Come on, ask me.
Nobody.
No one wants to tell.
For this one, could we do like I don't know the name, but when you get a vaccine, you have the thing that you apply the vaccine would it be the same thing as in the rocket when you put your finger into the hole and then and then you pull the thing that it goes back? Could it be the same thing? The
Mm.
syringe.
Mm. You're saying put your finger in the hole here?
No.
Trying to ask you if this is the same behavior when you apply some medicine with syringe. But
The same thing as a syringe?
yeah,
Yeah, because when you
Yeah.
put it in the hole, oh, we don't know the name. I'll translate it and then I'll ask you
So when
again.
you're trying to apply an injection, instead of the needle, you put your finger pressing the top of the injection. So it causes that pressure. That when
Yeah,
you
that's it.
that you feel the pressure instead of the when you're doing a kind of injection or vaccination or something.
Okay.
So that's it's the same system.
Yeah, same system. Well, what it is this action force. The Newton's law is for every action force is an equal and opposite reaction force.
Mhm.
So if you apply a lot of pressure there, you're going to get a lot of reaction responding to that pressure. Action, reaction. But you've got to add the word force to those words. Otherwise, the kids don't even know what that is. Action, reaction, any action force versus reaction force.
I think the suggestion of the rocket would be incredible for you to create a lesson for the kids because the material is very simple. They have this, I'm going to use the word that they have in Portuguese. They have massinha de modelar. The kids have at home. They have bottle. They have straw. And it's very simple to use to the kids. And you can give a kind of lesson, explain something about a rocket. This is really good. They will love, the kids will do. And you can challenge the kids like John challenged you. I mean, who's going further? Test with different sizes. Create different size of rockets. See and give and return to you. Remember that when you are creating the activity for the kids, you will receive the answer. So you can challenge the kids like this. Who went further? Calculate how many meters you got. So the kids will love it. This is going to be awesome for them.
Well, those are different things I've got for you today, Professor Antonio. There are more rockets to come if you want them. I've got different kinds as we go down the road. In my graduate classes, the kids have to create different one. They got to create a water rocket, a rocket that is powered by water pressure using a bicycle pump.
Yeah, Luisa that was talking to you, Luisa and Bruna. Is Bruna here in the classroom? I'm not sure. I have two screens.
Yes.
Is Bruna here? Yeah, Bruna and Luisa, John. They were 2 years ago champion here of water rockets. How many meters your rocket got, Luisa? 100?
75.
100? 200?
No, 75.
175 meters. The rockets. There's a competition in Brazil.
Very good. Very good. Very good. Well, any other questions?
No, friends? Are you sure? So, John, it was
Yes, sir.
incredible having you here with us in the middle of a Wednesday. Thank you so much. I'm sure that you inspired Vince a lot to create some activities for the kids because, as you told us, you have to learn by doing. And when you
have to learn by doing. Yes, sir.
You learn much better. So thank you so much. In the name of the students, the name of the group of Conheciência, would like to say so much for your help. Anyone would like to say anything to Iris family would like to say anything before I close the class?
Yes.
Anybody else? No? Okay,
Nobody else. Okay.
okay, John, thank you so much.
And
People,
thank you for inviting me
so
to your
much for
class.
being here with us. Let's give an applause for John, please, because the class was really incredible. He was in the United States just teaching you. Thank you, John. Thank you. And now I
Yeah.
hope you come back to Brazil to have dinner again together.
I'm ready. Whenever you ask me, I'm ready to come.
Perfect. You're vaccinated, so you can come to Brazil.
Fully vaccinated.
Yeah, perfect. Okay, people.
All right. Thank you then, and good night to you, and
Good night.
God bless
Thank you
you
so
all.
much. See
Bye-bye.
you, people. Thank you. The recording
Thank you.
YouTube channel of
Bye-bye, Melinda. Bye-bye, Rosano. Bye-bye.
Bye. Bye.